Okay, chapter 1.7 energy, guys. Let's look through the first question here. What do they want from you? A stone of mass m is held at rest in the water. The stone is released and falls vertically through a distance h. The stone reaches a speed of v here. Some of the original energy of the stone is transferred to the water as it falls. Resistive forces causes the temperature of the stone to increase. Which expression gives the work done against these resistive forces here? Now, this first things first, this question here, they're actually trying to test your understanding on principle of conservation of energy. In this case here, it is a typical scenario where the potential energy converts some energy into kinetic energy, whereas some energy is converted into heat energy. Now, if I want to draw the diagram here, right, it will look something like this. So there is a stone, there is resting on top of the water with a mass m here. It will fall a certain distance of h here. It will reach a velocity of v at the end of the day, and then in between the top to the bottom, right, this is obviously going to be potential energy, right? And at the bottom here, the potential energy has converted into kinetic energy here. Now, in between these two potential and kinetic energy here, some of the energy was lost, and that energy that was lost is actually used to increase the temperature of the water. So from here, let's assume, right, at the start of the stone, right, it had 100% of energy. Then some of the energy was converted into kinetic energy. Let's say 80% of the potential energy was converted into kinetic energy. So where did the rest of the 20% go? The rest of the 20% is actually converted into heat energy here, right? So from here, they ask us which equation gives the work done against the resistive forces that was responsible for increasing the temperature. It's obviously going to be Boy here. Why? Because 100% minus 80% is the 20% of the heat energy gained by the temperature, right? So this is how you're supposed to solve this question here. Looking at the second question here, which energy resources do not derive energy from the sun? There are only three known resources that do not derive energy from the sun. That's geothermal, which is energy from the Earth's core. It is tidal, which is the gravitational pull from the moon. And then the final one is nuclear, which is uranium for the nuclear power plant. So looking at this question here, obviously A is the only one. Some processes are more efficient than others. Which expression gives the efficiency of the process? Total energy output over total energy input. This could be possible. Useful energy output over total energy output. This is more likely. Wasted energy output, no. Wasted energy input, no. Yeah, answer is definitely going to be B here. Now, when we're dealing with these kind of questions, you have to be very careful because although the equation is output over input times 100%, the real equation is useful output over total input times 100%. So this one here is just a play of words, guys. Right? And looking at this question here, what do they want from you? The diagram shows the energy used by modern lamp. So you start off with inputting 60 watts of electrical power. 12 watts of it was used as output light and 48 of it was wasted in heat surrounding. Which expression gives the efficiency of the lamp? Obviously this one here is total output over total input times 100%, which is going to be A here. Nothing much to explain there. Then three boxes, each weigh 100 Newton. A man lifts all the boxes together from the ground onto the shelf that is 1.5 meters above the ground. The man takes 2 seconds to do this. How much useful power does the man produce to lift this box? The power is supposed to be energy over time. In this case here, since I have the force, I have the distance, this is obviously work done over time, which is going to be force times distance. Force times distance over time, right? But in this case here, a lot of students, they actually do 100 multiply by 1.5 and divide by 2, and they think they're done with the question. But in reality, there are 3 boxes here. So instead of 100, it's going to be 300 times 1.5 divided by 2. Right, so in this case here, it will be 300 multiplied by 1.5 divided by 2. You'll get a total of 225. 225 watts. Alright. Then looking at this next part here, this is also a very interesting question that students always get wrong. Guys, look at this question here. What do they want from you? First and foremost, it says that the cabin used to transport passengers up a hill. Right. The cabin is attached to the cable which moves horizontally from A to B. Horizontally from A to B. And then uphill from B to C. Uphill from B to C. There is an electrical input of energy to the motor which moves the cable. Place 2 ticks against the type of energy that increases as the cabin moves horizontally at a constant speed. Which energy is going to increase? Now the first option here, they give you the kinetic energy of the cabin. This is definitely not true. Why? Because while it is moving, it will have kinetic energy. Since it is moving at constant speed, it did not have an increase. It did not have an increase in the kinetic energy. So A is definitely, the first one is not an option. Gravitational potential energy is definitely not possible as well, because the cabin is moving at a horizontal motion, right? Horizontal motion means to say no gain in height, means no gain in gravitational potential energy. The internal energy of the surrounding is going to increase for sure. Internal energy is anything that has heat, right? So in this case here, they're saying that the heat in the surrounding is going to increase. Definitely true, because there's going to be output of energy and there's going to be moving components, right? And the internal energy of the wire of the motor is going to be increased as well. Why? Because as the wire moves, it is going to have friction against all the other pulleys, right? This is definitely going to generate heat, which will in turn create internal energy of the wire, right? The cabin and the passengers have a total mass of 800 kg. The vertical distance between B to C is 50 meters. Calculate the increase in gravitational potential energy when it moves from B to C. Now, gravitational potential energy has a very simple formula of mgh, right? In this case here, it will be 800 multiplied by 9.8 multiplied by 50 here. So if you press all of this into the calculator, 800 times 9.8 times 50, you'll get a total amount of energy of 392,000 joules, which we always change it into standard form, which is going to be 3.92 times 10 to the power of 1, 2, 3, 4, 5 joules here. Alright, very straightforward question. Now after that, the cabin then descends back from C to B. The weight of the cabin pulls the cable, which rotates the motor. The electric motor acts as a generator when rotated in this way. Explain the environmental and economical benefits of this arrangement. Now, environmental benefits are definitely going to be things like less carbon dioxide produced, less pollution produced due to the less energy used, right? And the economical benefits is basically talking about dollars and cents. Whenever they talk about economical benefits, they're asking how does this arrangement help reduce the cost of producing energy, which if you think about it kind of makes sense, right? As it goes down, the gravitational potential energy is going to pull the cabin downwards, right? This actually causes it to generate electricity on its own, meaning to say the overall operation is going to require much less energy, because as it goes down, it creates its own energy in this scenario here. So for this question here, right, you can write something like, as the cabin descends downwards, it converts gravitational potential energy to kinetic energy. This reduces the need to produce excessive amounts of energy, which helps with the reduction of pollution generated. By doing so, it also reduces the cost of energy produced, because every time it goes downwards, it generates energy back into the motor itself. Alright? Then, Moving on to the next question here. What do they want from you? As a box of mass m slides down a slope of length L and a vertical height D against friction F here. So there's M, there's F, there's D, there's L. As the box slides down the slope, it loses gravitational potential energy and it does work against the friction. Which rho gives the loss in gravitational potential energy and work done against the friction? Now you guys have to remember this, whenever we're talking about gravitational potential energy, the height that we are concerned of is always going to be the vertical height, none other. So looking at this question here, this is the only vertical height, right? So mgd is the only logical one. And since we're talking about work done as well, work done is always going to be force parallel to its displacement. If the force is in this direction, the distance must be parallel to its force, right? So its answer is definitely going to be A in this scenario here lah. Right. Then question number 2 here, the diagram represents the energy transferred for a device. The device is 50% efficient. Which equation is correct? Input energy is equals to useful energy. This is not logical. Useful output energy equals to wasted energy. This is not logical as well. Wasted output energy equals to useful output energy. This is possible since it's 50%, right? It's basically saying like 100 here, 50 here, and 50 here, since they're the same, right? Wasted output energy equals to blah, blah, blah. No, answer is definitely going to be C for this scenario here, yeah? And after that, a student carries out some simple exercises in which exercise is the most work done. Work done is always going to be force times distance, right? So this one here, if it's lifted up 1 meter, the force will be 10 newtons. The work done will be 10 joules here. This one is lifted 2 meters, the newton here will be 20 newtons, so it's 40 joules here. This one here will be force times distance, which is just 4 joules. This one here will be force times distance, which is only just 4 joules. So the answer here is going to be C, guys. Always remember to convert your mass into weight first before you do the work done formula. Then the next part here, an object falls from a height of 5 meters. Air resistance can be ignored. Now, I've mentioned this many times in class. As soon as you see the word air resistance is ignored, you can safely assume that potential energy is fully converted into kinetic energy or vice versa, guys. As hit the ground, the object has 750 joules of kinetic energy. What is its mass? From here, I can write down the equation since potential energy equals to kinetic energy, right? Let me write this down here. Potential energy equals to kinetic energy here. mgh is equals to half mv squared. In this scenario here, I don't even need this half mv squared. I can straight away substitute everything in here, which is 750 joules. I'll just go with m is equals to 750 divided by gravity, which is 10 in this question here because it's an old question. 10 divide by the height, which was 5 here. So it's essentially 750 divide by 50 here. 750 divide by 50, you'll get an exact answer of 15 kg here. Oh, you can't do this question yet, guys, for most of you, unless you're watching this video later on. An electrical generator produces a electromotive force of 200 volts, produces a current at 30 amperes. The generator drives a power of blah blah blah. What is the efficiency? Power is equals to volt. Power is equals to volts times current, which is 200 times 3. You have 600. 600 divided by 2,400. You'll get 25%. Okay. The diagram shows the athlete training by stretching springs. Each spring has the same stiffness. Which athlete does the most work? One stretches by 0.6, one stretches by 0.8, one stretches 2 by 0.6, and one stretches 2 by 0.8. Obviously, donkey is the answer here. It's just logical, common sense, right? Now, this question is a bit interesting though. A steel ball is fired vertically upwards with a velocity v. The ball reaches a height h. The same ball is now fired vertically upwards from the same position with a velocity of 2v. Air resistance can be ignored. What is the new height reached by the ball? Now this question here, yet again they mentioned that air resistance can be ignored. Now from here I can straight away assume that all kinetic energy is fully converted into potential energy here. Now if I were to write the equation here, it will be half mv squared is equals to mgh, and since there is both mass component on the left and right, I can cut it away, right? And I know for a fact that half v squared is equals to gh. Half v squared is equals to gh here. Now originally when they use a velocity of v, it reached a height of h, right? Right now they're looking for velocity of double the velocity 2v. They're asking about what is the new height reached. Now since there is a square component in your v here, you have to understand that when you double up the velocity, you are actually going to quadruple up the height. So if I were to write this down in equation, right, it will be basically like half 2v squared is equals to gx in this scenario here, right? So from here it will be basically half times 4v squared equals to gx in this scenario here, which is cut. You'll get 2v squared equals to gx. Okay, you'll get 2v squared equals to gx here. Now, once I have this equation, right, let's compare this equation here versus this equation here. You can see that on the left hand side here, right, initially it was just half v squared. I was able to reach a total height of h. Now when I have 2v squared here, coming from here to here, guys, it is a multiple of 4, right? So looking at the h component, it should be a multiple of 4 as well, and that is why the answer here should be C, right? Now this question is a bit complicated, guys. You might need me to explain this in real person, but just hold this in mind first, guys. It's basically going to be when you double the velocity, you're going to quadruple the height. If you triple the velocity, you'll times 9 the height, simply because of the square component here, guys. That's the easiest way to look at it. Then looking at this next part here, a solar panel is used to recharge a battery. The solar panel produces 0.8 watts of electrical power and is 20% efficient. What is the power input of the sunlight on the solar panel here? Right, so basically they say that this 0.8 watts is only 20%, you know. So if 0.8 watts is equals to 20%, 100% will be basically multiplying by 5, right? Which is essentially going to be 0.8 multiplied by 5, which is going to be 4 watts away, guys. 4 watts is going to be 100%. 0.8 watts is going to be 20% here, right? Then the diagram shows 4 different athletes training by doing pull-up. Which athlete does the most work? Work is yet again force times distance. This one here will be force times distance, 350 joules. Force times distance, which will be obviously a little bit more. This one have greater force. Obviously, we're going to find the one with the greatest force and the greatest distance, right? So donkey is definitely going to be the answer here. This is going to be another year 11 question, guys, because you have volts and power. So most of you guys will probably not be able to do this, but you can ignore it if you're still in year 10. The rate at which a lamp transfers energy to the surrounding. Now, whenever you see this word rate, guys, rate is always going to be something over time, right? In this case here, they say the rate of energy, right? Which is essentially going to be energy over time. Energy over time is going to give you the power equation. So if you see it's only 1 mark here, is because it is exactly, the answer is looking at you, guys. It's going to be 60 watts here. Name the name of the thermal process by which the lamp transfer energy to the surrounding. Thermal process where the lamp transfers energy. I don't know, it could be conduction, it could be convection, it could be also radiation. It doesn't really matter, right? Figure 3.1 shows a collision between two blocks A and B on a smooth surface. Suggest why the total kinetic energy of block A and B after the collision is less than the kinetic energy of block A before the collision here. So they're basically saying that how come the total energy here is less than the total kinetic energy here before the collision, right? You have to understand that in a real life scenario, energy will never be fully like transferred, right? Some of the energy will always be lost to the surrounding, and this is a very, very popular IGCSE question. Whenever you see these kind of questions here, right, you have to understand that the reason why you won't get the full amount of energy is because some of the energy was converted into heat and lost to the surrounding, guys. So if I were to write this down, it will be something like some energy was converted or lost to the surrounding as heat or sound. A very typical question with a very typical answer, guys. Whenever they're asking why the energy is not full or whatever, right, it's always going to be because the energy is lost to the surrounding as heat or sound, right? And moving on. A metal block A travels in a straight line at 0.4 meters per second on a smooth surface, collides with the metal block B, which is at rest. Blah, blah, blah. After the collision, yeah, this is essentially going to be the exact same answer as well, right? Because the energy will be lost to the surrounding as heat or sound, guys. So, copy, paste. Wait. A machine is very efficient. What does this mean? It produces a large amount of energy? No. It uses very little energy? No. It wastes very little energy. Whenever we say something is very efficient, it means to say it wastes very little amount of energy. A crane takes 2 minutes to lift a load to the top of the building. The change in gravitational potential energy of the load is 360 kilojoules. Guys, bear in mind this kilojoules, so it's going to be 36000 joules. What is the useful power output of the crane? Power is going to be energy over time. You have to convert this into seconds, right? Which is going to be 360,000 divided by 120. Which is going to be somewhere around 3,000, right? Yeah, so 3k watts, guys. A force Fx on the body and the body moves a distance d in the direction of the force. Which expression? This one is no-brainer. Obviously, it's force times distance. A boy produces an average power output of 60 watts as he rides a bicycle for 2 minutes. What is the energy? Yet again, you have to convert this into seconds, guys, right? So it's basically going to be power times time, which is, since power is equals to energy over time, energy will be equals to power times time, which is 60 times 120 here, which is going to give you 7,200 joules here. What is the correct expression for? Yeah, this one is a no-brainer. Gravitational potential energy is just going to be mgh, regardless of however you want to change it. Then a box is pulled along a floor by a force of 3 newtons. The friction X on the box is 1 newton. How much kinetic energy does the box gain in moving 2 meters? Oh, moving 2 meters. It's basically going to be force times distance, right? Which is going to be 3 times 2 here. It's definitely going to be 6 here, guys. Oh, sorry, not 3 times 2, sorry. it's going to be a resultant force of 2 newtons here multiplied by this distance here, which is going to be 4 joules, guys. It's supposed to be resultant force times the distance. So yeah, it's going to be 4 joules. Okay, looking at this next question here, what do they want from you? Figure 3.1 shows a solar cell used to generate electrical energy. First question, state the main form of energy transferred from the sun to the solar cells for the generation of this electrical energy. This one here is a no-brainer, right? Obviously, this is going to be light energy that is being transferred, or you could even write solar energy that is being transferred from the sun to the solar cells, right? So nothing much to explain here. Then moving on to the next part, consider the generation of electrical energy by a large number of solar cells as shown in figure 3.1. State one environmental advantage and one environmental disadvantage here. Obviously, whenever we're talking about all these solar cells, right, the environmental advantage is that we do not need to burn coal or fuel or whatever to produce all the CO2 gases that is going to be harmful to the environment. But whenever we talk about disadvantages here, obviously there are many environmental disadvantages as well. Number one, solar panels, they require a large piece of land to function, right? And number two is there could also be pollution produced when you're setting up the solar farm as well, because it doesn't just pop up out of nowhere. You have to use infrastructure, you have to use all the old machineries and everything, which is still going to produce wasteful byproducts, guys. So looking at this question here, the first advantage of this is that in the long run, it produces much less harmful CO2 gases, and less pollution. Then after that, the disadvantages here is obviously that it requires a huge amount of space. It requires a huge amount of land or space. Doesn't really matter. Okay. Then state to explain whether the source of electrical energy is renewable or not. Obviously, your statement is yes, it is renewable. Why? Because you cannot finish using it, right? It cannot be used up. Okay. And this is how you're supposed to answer these kind of questions here. Then this next part here, yet again, you can't do it because it's part of the year 11 syllabus. Just ignore it straight away. Figure 2.1 is the top view of a small ship of mass 1.2 kg. Okay, this is a piece of information, which is the mass. Its ship is moving slowly sideways at blah blah blah. This is the velocity. The ship hits the wooden pillar which moves towards the dock wall. Calculate the kinetic energy of the ship before it hits the pillar. This one here is a very straightforward one. Kinetic energy is equals to half mv squared. In this case here, it will be half times 1.2 times 10 to the power of 6 multiplied by 0.04 square here. You press that into your calculator. 0.5 times 0.04 squared times 1.2 times 10 to the power of 6. You'll get an exact answer of 960 joules. You'll get exactly 960 joules here. Okay. And moving on to the next part here, the diagram shows part of a roller coaster with a car at different positions. The car runs freely down from position X to Y and up the hill on the other side. What happens to the kinetic energy and to the gravitational potential energy of the car as it moves from X to Y here? Kinetic energy obviously is going to increase, right? So C and D is going to be the answer. Gravitational potential energy is obviously going to decrease. So answer can be no other than C in this scenario here, guys. Which energy does not have sun as the original source? Yet again, I mentioned this before, geothermal, tidal and nuclear do not derive energy from the sun. Everything else derives energy from the sun. Which source is not renewable? Nuclear fission is definitely not renewable because it burns nuclear uranium, right? Uranium and plutonium lah. Then a car of mass 500 kg is moving at 10 meters per second. The engine does work on the car and the speed increases to 16 meters per second. How much work is done by the engine to increase the speed of the car here? Now basically you have to find the initial kinetic energy and the final kinetic energy. Whatever difference this is, that will be the work done to increase the speed, right? So it's basically going to be half mv square minus half mv square here. Since we have both the same equations, it will be half m v square 1 minus v square 2 here, right? From here, press everything into the calculator. It will be 0.5 multiplied by 500 multiplied by bracket 16 square minus 10 square here. You should be able to get a final answer of 39,000 joules. Okay, and moving on to the next question here. A mass bounces up and down on a spring, on a steel spring. The diagram shows the mass of the spring at different points during the motion. At which point does the mass have the least gravitational potential energy, and which point does it have the most elastic energy stored? The least gravitational potential energy is when it's at the lowest point, so obviously it's either going to be between C and donkey. And the most elastic energy stored is when it is stretched the most or it is compressed the most, right? So looking at this question here, the stretch the most is obviously going to be the lowest point again. So donkey. And finally, looking at this question here, the velocity of v of an object increases as it falls towards the ground. Which quantity is directly proportional to the v square here? The speed of the object, possible. The gravitational potential energy of the object, possible as well. The kinetic energy of the object, definitely, because kinetic energy is equals to half mv square, right? State the name of the form of energy stored in the two springs when they are stretched. This is obviously going to be elastic energy. State and explain one advantage and one disadvantage of heating water in solar panels compared with heating water in a coal burning boiler here. Obviously one is going to be renewable and one is going to be non-renewable, right? So the advantage here is that obviously it's going to be renewable, right? Why? The explanation is because no air pollution is produced. And the disadvantage is going to be it is not readily available. Solar panels are always going to be dependent. It's going to be dependent on the weather, right? It's because solar panels it is always going to be dependent on the weather. If today there is sun, then there is heat. No sun, then there is going to be no heat. And this one here is another question. Yeah, that's it. Right, so that will be it for this chapter here, guys.